Right. So I want to work today on our PNG loader a little bit. We've gotten pretty far. We are trying to basically write this application that will let me generate color correction profiles as a way to kind of like trick my monitor slash GPU into playing or into like displaying things in a way that's like a little bit nicer. I'm playing this game Io.Readers. It's too freaking dark. I changed about settings on my monitor to make things brighter. Speaking of, I need to change it to make it look correct because I was just playing yesterday. And so the idea is that like I want to be able to like have these images on screen, basically play with them till I think that they look good, add a few more settings to this thing, output them, right? PNGs have embedded color correction information in them that we are not respecting right now when we load this in with SDB image. So we're like, okay, we've wanted to write our own PNG loader for a while, so we might as well do that now. Which brings us to today, where we have this guy who, if we run this little demo app, that basically opens a PNG and converts it into like a PPM, which is just like the world's simplest output format. We can do that. So, if we go like this, we can look at this guy, boom, and that is a PNG that like resembles the one we were looking at before. It's really dark, but like whatever. We can also look at PNG res smile to test PPM. Boom. Okay. So this thing, the way it works, hand wavy, is we designed an API that's supposed to be like pretty freaking flexible. So maybe the easiest way to explain this is to talk about the overall format of a PNG. So it's kind of like PNG. And at the top, they kind of have like a signature that says like, I'm a PNG. You like open the first bit, you look at it, you go, yep, that sure is a PNG. And then after that, it's all like this generic mechanism of chunks, I think they call them. Maybe blocks, chunks, they probably call them chunks. And each chunk is like, I guess this is probably like 8 bytes wide. So each chunk has like 4-letter type code. So like it might say like I header with like the length of the data. So like len, these are 4 bytes each. Then you have like data in here. And then at the end, you have like a little, I guess it's easier to like draw it on the right side so it lines up nice. A little 4-byte CRC. And then you have like another chunk. There are many chunks that are like defined by the spec. But there are also chunks which you could have, they're like private chunks that aren't defined by the spec, and like your parser will just kind of skip over those if you don't support them. And so like our API kind of walks this structure and exposes each block. Sometimes it will like interpret them. If it's like a really cheap block, like only maybe a few bytes long, and we know how to interpret it, we'll just give back a struct that represents what was in there. But in some other cases, maybe we don't know what the block is yet, and so we want to like expose that to color and let them read it, right? And then in some cases, the data is like really complex, but we know what it is, right? So an example of that would be data segments. The data segment is kind of what is it? It's a bunch of data segments that are kind of back to back. DAT. IDAT, I guess is what they call them. IDAT, IDAT, IDAT. When you take all these chunks together, hold on, we need to like make this a little bigger. When you take all of these chunks together, this is one zlib compressed block. Compressed. Then, when you decompress that block, you end up with something that is almost your PNG data, but not quite. It's kind of like you have like your image, and then on each row, you kind of like prepend a filter. F, 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 F. And this filter basically will like adjust the data based off of what's behind it, like one row up and maybe like behind it in the row to kind of figure out, it tries to like encode the data in a way that will make the compression better, basically. Like, so maybe make all of the numbers smaller, something so that there's less characters in the alphabet that you need to compress, stuff like that. Maybe more repetition, that kind of thing. And so then after this, then we decode this, and this is our output image, right? So we have an IO pipeline. So back to the idea of like allowing lazy read by the caller. If we want the caller to choose how much they want to read, maybe they want to just look at the metadata and not look at this data segment. Maybe not, right? Maybe they want to look just at like, I don't know, maybe they want to look at the data, maybe they want to look at the header, maybe they want to look at like one of the custom format segments, like whatever. So we want to expose this as like a lazy read thing. So we construct an IO pipeline that's like file maybe, or like in source to merger to decompressor to like unfilter. And then this goes to like the user, right? And so this makes use of like Zig's Io.Reader interface, right? Basically, like they have an interface that allows you to provide these transformations. This one's provided by the standard library. And if we if we want to like CRC check this thing, make sure that like the data that we read is valid, we kind of have to like inject something into this pipeline, I think. That's kind of where my brain is right now, where like it probably goes like in here. Maybe the merger is responsible for calculating CRCs as it merges or something. And then for the other segments, we do it somewhere else. I'm not really sure. But my gut says that we want some sort of reader structure, that takes some input and pipes the input to some output. And just like in between holds in the CRC and just like kind of snoops on what is being passed along and calculates the CRC as it goes. And then at the end, we can query the CRC and go like, okay, what'd you get? Right? That's kind of the idea here. I don't really know how we're going to make this thing, but I assume that we'll be able to figure something out. Yeah. Okay, so I guess step one, probably step one is to actually figure out like what is the CRC. So if I remember correctly, CRCs are based off of like Wikipedia. They're based off of this like common thing in this space, which is kind of like polynomial math, but only within this, like, I think they call them Galois fields, where the Galois field is 2, which means that like each polynomial can only be 0 or 1, right? So you write something like they kind of work on this math where they do like, you know, x squared plus x plus 1 plus x to the 5. This might be a polynomial, and if you were to like add this another polynomial, like maybe you would add x to the 4 plus x squared plus x to this polynomial, like because it's in Galois 2, basically when you add these two numbers, like the addition will cancel out, so this becomes like 1. These x's become 2x, which is mod 2, which is 0. So this x goes away. This x squared also goes away. This x4 shows up. x4, and this x5 shows up. And you can do like a bunch of math in this world, where a bunch of like the rules kind of make it so that you can calculate how to prove that things work the way you expect them to. I don't really know. I'm not a math guy, right? But the convenient thing about this particular number space is that you can represent this polynomial as 1, 1, 1. You skip x to the 3, x to the 4, and you get x to the 5. Each bit here in this pattern represents one of these parts of the polynomial. And then addition in this space becomes XOR, right? So you represent this guy as what? This is 0, 1, 1, add the 4, 3, and 5 are not there. And you XOR these together, and you end up with 1, 1, 0, 0, 0, 1. Right, which is the same as x to the 5 plus x to the 4 plus 1, right? So hand wavy, this is kind of what you kind of need this background to understand when you look up things like PNG spec. In here, they're going to talk about like CRC. And in here, they're going to start showing you stuff like this, right? And you're like, what the fuck is this? And it's like, oh, this is just a number, right? So CRC is probably, I think it defines like some amount of operations that you do on a thing, right? And they kind of say, hey, you have like some initial state, you feed in more state as you go, and you have like some maybe optional things that you do at the beginning and end. But the important part here is that like this is your like initial state, I think. CRC fields are calculated using standard CRC methods with pre and post conditioning as defined by this spec. The CRC polynomial employed, which is identical to that used in the gzip file format, is this. Oh, maybe it's not. Sorry, this might not be the initial state. You might like XOR your data with this thing as you're going or something before you do some other operation. I don't remember. It's also not super important because the Zig standard library has what is it, hash CRC. And in here, the reason that we have to talk about this a little bit is because there's like a million different CRC options in this file, but all of them kind of have like the similar options, right? So reflect input and reflect output, I believe, are just like sometimes you have like an input number, input data. Sometimes you just like fucking negate that shit on the way in and out of the CRC. I don't remember why you do that, or maybe that's XOR output. Reflect input output might be bit switching, like from 10000 to goes to like 00001. It's probably something like that. XOR output is like sometimes at the end you just like negate the I can't remember. We could look. We could look. Reflect input. Yeah, so reflect input, they do a bit reversal, so that's what we just guessed there. XOR output says if we XOR output, oh, I see. You might just XOR the output with some specific number. Who knows why? There's probably some sort of mathematical reason why you might want to do that. And then what other options do we have here? So this is the value that you'll XOR with at the end. This is the initial state. This is the polynomial, and this is whether or not you bit reverse the inputs. Okay. Seems reasonable. And now the question is, it's like, which one of these like 500 CRC implementations matches the one we care about? So we are matching gzip, which I believe we also saw in the standard library, under stud compress flate. Here, it looks like in the gzip version, they just use the default CRC32, which is ISO HDLC, which is this polynomial, double reflect, XOR initial. Okay, so is this the same? Defined by this guy. HDLC, promising. ISO HDLC. Okay, so we have like maybe like 3 touch points to say that these are the same. We could check the polynomial as well. I guess we might as well. Just for one final bit of comfort. So can we do this? Can we pin this? It's not easy to pin it on top from here. I guess we go like this. Python 3. Python 3. Okay. So here we want, I guess we do like this. 32, 26, 23, 22, 16, 12, 11, 10, 8, 7, 5, 4, 2, 1, 0. So these are the exponents. And then we go like 4 exponents, 4 x in exponents. Can we do something like res, I guess we need, hold on, we need like val equals 0. For x in exponents, we want to do something like val or equals 1 shifted to the left by x. Wait, how is that possible? Then we could do like format x here. Val, I mean. Oh, because, oh, right. So another piece of info here is that the CRC has an implicit leading bit here. So a 32-bit number can't store this entire polynomial, but it can store the entire polynomial if you assume that there's an x to the 32 in there, which I think is what they're doing. Right, so the part we care about is this part of the number, 04C1, 04C1, 1DB7, which I believe is the same polynomial that we saw wherever the fuck we just were. 04C1, 1DB7, yeah. So we have like, that's one more touch point. That's like 4 touch points of things looking about right. We could be a little bit more careful, but I think that's sufficient for us to start and just kind of see where that goes. I think that's reasonable. So I would maybe like to do something where we, as we step through all of these things, we have like a discard CRC all over the place. Maybe we start with the fizz section, since this, we all kind of handle this inline. This is like this segment of the PNG maps basically pixel units to like physical units in meters, if I remember correctly. So we could here, just before we look at this, we could maybe say, hey, how big is this supposed to be? We could do like this. We could do temp is self input peak PNG fizz size, right? Buff. And can we just compute the CRC using the standard library and see if we get the same thing? Maybe we do this. So this is going to be data is buff from 0 to PNG fizz size, and the CRC, like data CRC, is buff from PNG fizz dot size onwards. And then we can check if we get the same fucking thing here, right? He doesn't like this because this has to be tried probably. Yeah, nice. So the CRC hasher is stud hash CRC 32. We get the default bad boy. And I think we can just go like hasher update with data. And then computed CRC is hasher final. Fuck off, you stupid fucking bot. Thank you. Actually, maybe I didn't get that wrong, right? That guy was just advertising a promo site. I could have got that wrong. Actually. OS, Nix OS. If that guy was just saying that if that guy just said that this chat has the best viewers, then I apologize for banning him. But I think that he was saying that I can buy the best viewers. And in that case, go fuck yourself. But I probably should have double checked. I would roast you was really human. Perfect. Okay. So now we should be able to be like, give me. Oh, we did this already. Give me the computed CRC, and I guess, can we just print as bytes, maybe? I need to check like the endianness of this thing. So as bytes computed CRC versus data CRC. You just make a banned word in chat. Yeah, but my chat isn't big enough that I really need to care that much. Okay, so bad news bears. We're not getting the same thing. That is bad news bears for sure. So I guess we have to figure this out. It's not even like reversed or anything. These things are just not even correlated, right? So let's double check for a second. CRC algorithm. In the PNG, 32-bit CRCs are initialized to all ones. Then the data from it. Oh. Hold on. Hold. That's all ones. Okay. And then the data from each byte is processed from the least significant bit to the most significant bit. The data from each byte. Oh, so we might want to reflect input false, or maybe that's correct. After all the data bytes are processed, the CRC is inverted. Its one's complement is taken. So that's this XOR output. The value is transmitted, stored in the data stream, MSB first, for the purpose of separating into terms and bytes ordering the least significant of the CRC32 is defined by the coefficient of the x to the 31 term. Oh, so we might want like a bit reverse of the final thing. No. Can we show maybe the binary representation of this thing? And data CRC is going to be maybe interpreted as a std math or std format parse int. No, mem bytes as value, maybe. Yeah, but doesn't this need to take into account like the endiness? Read int. There we go. So I think that we transmit everything big endian here. So maybe like this. What's he pissed about? What's he mad about? Is it that if I want to view the binary representation, I have to do something else? Doesn't reader have taken? Yeah, but I don't want to use that right now because I don't want to like consume the things that it's not supposed to. It's not 0xFFFFFF. Maybe I missed something. Peek int. Yeah, but I'm trying to peek like many int. So I'm trying to like peek a big slice and then peek the parts of that slice that I care about. I could make another reader over that slice, but it's easier for me to just do it by hand. Okay, can we look at their sample CRC implementation? Oh, is there polynomial fucking backwards too? It might be. It might be. Hold on. Well, first let's figure out how to format these things as binary. B. Wait, so why can't I do... Oh, because I did as bytes like a dumbass. I'm an idiot. That's why. Okay. Do these things resemble each other in any way? One, 0, 1. No, these do not resemble each other at all. Okay. So it's not like a simple bit reverse. New line is your friend? Yeah, I agree. Yeah, I don't really see anything in here that resembles each other at all. So I guess that means that we have to be a little bit more careful with the CRC implementation. So what are they doing? Okay. So they have input initial state, a bunch of Fs. They have XOR, a bunch of Fs, 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. Okay. So it feels like I suspect that the bug might be that it's expecting little endian or something. Can we do something like this? Const png crc. Can we do something like this? Maybe? Oh, my brain. Wait, why doesn't he like this? Like this. Do these resemble each other at all? No. Okay, we see them using in their implementation this polynomial. So let's just start doing this. Can we also take a quick glance at their implementation? So if reflect input, they are doing... Oh, they're using like the table version. So this is, oh, this is generating the table here. So make CRC table. Each value in their table is if C and 1, C is N, are they generating this the same way? They have an 8 here, an 8 here, 256 here, 256 here. So each, this matches. So we want like reflect input on, but with this polynomial, maybe. Well, but then they're doing like times poly. XOR CRC and 1 times poly. That's confusing. Okay, can we see if we see this guy anywhere in their... Oopsies, wrong thing. Like, is this polynomial anywhere in their thing? No, that never shows up, which makes me think that there's a chance that it's wrong to do that. I think it's not in standard library. Yeah, I mean, it might not be. Do you have test vectors? Yeah, maybe we should check some. Okay, so they're doing... We could try it. I think that we might have to start using our brains a little bit at some point. But not yet. Not yet. We just try a couple variants of this thing and see if any of them resemble. Okay. Wait. Oh, I got excited for a second. True, true. Okay. True, true. True, true. No. False, false. No. I don't think. Okay. False, true. Still no. True, false. Also completely unrelated. Why is this so fucking hard? Okay. So can we do the same with the other polynomial? Just to be 100% sure. I guarantee initial and XOR output are correct, right? So no. False, false, true, true. Oh wait, is this actually 1001? Yeah, okay. False, false. Can we make this how do you do this? Oh, whatever. I love that you're using visual similarities as a proxy for is this right method. Yeah. What else would you do? False, 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 true. Seems unrelated to me. True, false. Triple ones on one side, not on the other. True, true. Including the chunk type field and chunk data fields? Fuck. Did I miss that? I thought that it wasn't. But I'm an idiot. I might just be an idiot this whole time. If that says that, where would it say that? PNG image chunks. 4-byte, including the chunk type field and chunk data field, but not including the length field? Oh, because that makes it easier to generate and fill in later on the fly. Jesus Christ. Okay. So let's go back to this guy, and we need to first update with fuck. Okay. CRC, I guess we like initialize this guy. Can we do this? Chunk data is self input peak array for now. This just makes my life easier. So then we can throw this in here. And then this guy can be const. And then this update probably needs it to be ampersand here because it's an array. We need to try this thing before we dereference it. Okay. So now we can start doing a little bit of fiddling. That does not look related. False, false. Also doesn't look related. Okay. False, false. False, true. Wait. True, false. Is the poly correct? Unclear. I'm unclear so far if we're supposed to use the flipped one or not. Okay, I think I tried them all. So let's flip the polynomial again to the other one. Which is the backwards version of this thing. Unrelated. We'll try double true. Unrelated. True, false, and then false, true. Every single one of these is also not giving me what I want. God fucking damn it. we're not gonna, okay, let's read this again. We need to be a little bit more careful. I guess what we can also do here, we can copy paste their C implementation and shove some data into it and then compare that with one of the Zig implementations until we figure out what they're supposed to do. Maybe we do that. Test CRCC. Because clearly we don't understand something. Int main void, and can we shove in the data of hello world Sterling. Okay, const car star. S is hello world. And we're gonna do S and Sterling S. Because this will at least help us bisect what we're doing. Const. Really? Include string.h for Sterling. And then S, he's mad because it's supposed to be unsigned. I guess. Did you set the initial on that CRC? I believe I set it to the right thing. They said their initial was all ones. So I believe I did. Right? The 32 is initialized to all ones. So that we should have set the initial value in our structure. But like, how do I say this? Right? Like, they have initial value here. So it should be right, but maybe I mean, I think it's likely. I think we should, bisecting the problem here is way easier. Let's just do that. Let's just do that. Okay. Test crc.c. And then I guess we have like a unsigned long res is this, and then can we do printf res like this. Okay. Zig cc test crc test crcc. He does want lb, huh? Bum 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 bum. Okay. So what do we do with this? Maybe. Okay, so we have this guy, and then we want to do a similar test here. So we want const stud is equal to import stud. We got pub function main here. We got our s is hello world, which I guess we should actually straight copy paste in case we spell it wrong, which would be funny. We have stud hash crc 32, and then here we want to copy paste the initial parameters from this bad boy. Const crc, I guess we call this. Okay. Then we want to do pub crc init. Update with the string. And get the final value. And then print it. Okay. Okay, so good news. I think those are the same number. Yeah, okay. Good news. So actually just using the default CRC was right. The polynomial being formatted this way is correct because probably like the double reflecting is handling that the way we expect, right? So that's good to some extent, right? It means that this should get us the same answer. And so the fact that it's not means that it's probably a problem in our PNG reader stuff. Right, so can we go back to using just the default, this thing? And then what are we missing here? Is the PNG fizz size wrong? 1, 2, 3, 4, 5, 6, 7, 8, 9 seems right to me. Do they have padding that we have to account for? I don't see us doing any funny padding stuff, so I don't think so. That's not packed. Does it take extra bytes? I mean, when we read, so we're not reading the struct directly. We're reading like this. So it should be fine. It should be fine. We're not just saying like reader fill this struct. We're saying like read each value independently and put that in my struct, which is slightly different. Okay. So let's read again. We'll double check the CRC chunk thing. Maybe they CRC it with the value, the length value set to 0 initially. Right? Because you could imagine a world where they pre-populate this block of data, then CRC the block, and then put the value back in or something. Right? The CRC, a 4-byte CRC calculated on the preceding bytes in the chunk, including the chunk type field and chunk data fields, but not including the length field. The CRC can be used to check for corruption. See 5.5. Maybe we compare with someone else. libpng. Maybe. Okay. Could check SCP image. Does he do it? I assume he doesn't, but you are right, we could check. We could check. Maybe he does. And then we don't have to clone him to something new. Do PNG. Parse PNG file. Let's see. So here he's reading the header. He gets the header. He switches on the type, parses the type, and read and skip CRC. Unlucky. Unlucky. Oh, wait, we have current. Wait, I'm an idiot. Current source code. Source code. Tar goods. Let's just download the current. Hello? There we go. Okay. Lib PNG. Can we look for CRC in here? Okay! PNG calculate CRC. Push read IDAD. So he calculates the CRC looking at the PNG pointer. What PNG pointer? He's probably outputting the CRC there. This looks like save buffer. This is in a file called read, which makes me think that it's fine. Like, but PNG read.c. Okay, here we go. Wait, okay. So here we have PNG read end. Read the end of the PNG file. Will not pass. Read the end of the PNG file. Will not read past the end of the file. Will verify that the end is accurate, and will read any comments or time. Blah blah blah. Okay. So this is after. Oh, I see. This is like read the final end chunk. Oh, okay. So this is going to be called, in some case after some switch statement and loop, probably. So here is read PNG. Can we look for where he reads each chunk? He must read each chunk somewhere. Here he's in data. Can we look for a CRC in here? Okay, whatever. So this, when he's reading to the end, he reads the header, he reads the chunk name. Right, great. If the chunk name is not this thing, he does some stuff. Then he does some handle chunk stuff. And then does PNG CRC finish on the PNG pointer. So maybe read chunk header like initializes the CRC field. He might. Yeah. Reset the CRC and run it over the chunk name. And so he resets, and then he calculates the CRC from buff +4 onwards. Oh, did I just get the fucking length field and data field backwards? I might have. It's the length first. God damn it. God damn it. Peak 8 from 4 to 8 onwards. It's like this. Okay, there we go. Let's go! We got their fucking CRC, baby! Okay. Cool. So now we understand what we have to do, and the question is like, how do we do this? Because I think it really depends on like where we are discarding CRC right now. So can we look for calls to discard CRC and kind of just see who's doing this right now? So kind of like at each block that we handle, we call discard. In our iterator, if we have an unknown block, we read to the end of the block, then discard the CRC. That makes sense. And then in the merger, we discard CRC every once in a while. Okay. So to me, it feels like we have like many IO pipelines here. So we have like unknown is we have file reader to that gets converted into like limited reader, and we return this to the caller. And then before we like after the caller returns to us and like says go to the next step of the iterator, we like consume this iterator all the way. It kind of feels to me like there should be some sort of like CRC thing in here, maybe, is where this makes sense. Then we have the like, data case where it's like file goes to merger, because we merge multiple data segments. And this guy will parse a bunch of block headers, so like ... doesn't really matter. It feels like this guy owns probably CRC stuff, goes inside him. And then we have like other cases like known typical, where we kind of say like file and then directly to output, right? We just like parse it inline in these cases, in which case like the CRC reader can just kind of sit in here. But I think in all cases we can represent this thing as a reader. And the only thing is the initial chunk will be wrong. Or sorry, the initial chunk, we need to like inject the initial chunk header externally. I think if we want to keep doing things this way, where we read the chunk data up front and then choose what to do, and then construct the CRC reader differently depending, I think it makes sense that we feed the, like maybe we have like hasher here. Let's just try to handle one case now, and then we'll kind of figure out how it fits into the rest later. Yo, I've been wondering, how's it going? Wanted to ask, have you tried agent decoding? If so, did it work for you? I have not really. However, my understanding of this stuff, which could be wrong, is that CRC, my brain's melting. The agentic coding stuff still will just send queries to what is essentially the ChatGPT interface, right? Or whatever. Like it's essentially saying like, here is a string of text and predict the next thing. And every time I see one of these videos on the internet or people on Twitter posting about how it's so much better, I try doing something with an LLM just to check if my intuition is totally wrong. Yesterday was one of these days, and I was working on this like pixel abstraction for my image thing. So the idea here is that we get data from a PNG. It might be packed as RGB 888. It might be packed as RGB A8888. And I wanted to be able to like represent this as like a union where we have, you know, RGB 888 pixel and RGB A888 pixel, right? Something like this, right? And I was confused because I thought that if I had a packed struct of 3 bytes, so this could be like a packed U24 struct, right? I thought that this would pack in an array nicely so that you'd have like 3 bytes, 3 bytes, 3 bytes, 3 bytes, right? Every time you index, you get the next 3 bytes. That is not the case, right? Size of RGB 888 pixel is equal to 4, right? And so I asked an LLM, I asked multiple LLMs, and I got my friend who works at a company where they pay for access to better LLMs to like replicate the experiment. And I was like, I just asked, like essentially, when I make it in Zig, when I have an array, a slice of packed structs looking like this, where I paste this thing in, access is not the way I would like, right? I was hoping that packed structs would give me packing within a slice as well, right within a slice as well. When I check size of blah, 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 this is like, it says 4, not 3, like I would have hoped. Is there a way for to cast my bucket of bytes into packed arrays of 3 byte structures, or you know, something like this, right, along these lines? And the LLM, of the LLMs I tried, one of them said use a packed struct, and I am, and they're like, I'm like, I am, the packed struct has a size of 4, I need it to be 3, and they're like, run this experiment, the packed struct should have a size of 3. I'm like, it doesn't. And they're like, no, it does. Here, run this. And they give me like a little like function. There's like function main assert packed struct size is 3. And I'm like, that assertion fails. It's 4. And they're like, try grepping your code base to see if you're accidentally using the wrong type. And I'm like, fucking shoot me in the fucking face, man. Like, what the fuck are we doing? Right? Um, and then I ask like a different LM. Some of them tell me to try putting like make a struct that writes like a line one at the end of this. This isn't valid fucking Zig syntax, right? But I try like maybe saying that like my struct is line one, so it's no. But like multiple LLMs just tell me confidently that this thing that you can't fucking do in this language is like they're telling me I'm wrong and that I should do it their way. Or like just do this. And it's just wrong every time. And so it's like I can't imagine that like this is not complicated, right? I don't think this is particularly difficult. I get frustrated when these shitty fucking tools just lie to me and tell me the wrong thing. And every time I try them, maybe it's because I'm only trying them in like the wrong circumstances, but every fucking time I touch them, they're wrong, right? The only thing where they're like somewhat useful to me is when I can like ask them to explain something at like a 5-year-old's understanding level, and I can have easy ways to verify the answer. And so like while I haven't tried specifically the tools that run rampant on my computer, like, why in the fuck would I ever let them? Everything I ask them is wrong. They lie to me all the time. And so, like, why would I trust this, like, thing to execute code on my computer? I would never fucking do that. Right? Because they're such lying pieces of dumb shit. Right? Like, I, like, can see an argument for, like, if you're working with stuff that is essentially like stitching libraries together or something like that, like it's possible that would do an okay job, right? I was asking my friend whose company is like kind of like forcing them to use these tools a lot. I was like what scenarios does it help you in? And he's like, yeah, a lot of it's like kind of bullshit, and a lot of it you kind of have to like tell it it's wrong like 15 times in a row, and like it will just like fix a bug. You'll ask it to fix a bug, but like the way it fixes it doesn't address the root problem. But he's like, if you're like lurking, if you like have a data sheet for some piece of hardware that you're using, and you like feed in that data sheet and like an example, like say like something that we did at one company that I worked at was we kind of had like a interface of Zoom controller or something like this on like a camera I was working on, right? And we get like a new camera that has like a completely different API, and we're supposed to like implement iZoom controller on this like physical module controlled by an I2C bus or something, right? And like in that world, like I could see a world where you feed it in and it does the right thing, right? Like it or generates something that's like approximately like stubbing out the interfaces and like injecting the right calls to do the things that the datasheet says it will do. Like maybe. But like to me, it feels like my bottleneck is never writing code. Right? And so like my bottleneck is like figuring out which code to write. And so I just I don't see a world where like if I'm trying to figure out what the right code to write is. Surfo, do you actually need an answer? No. I know the problem now. I have a solution for this, right? It's this. Basically like index the data directly and then cast, right? I'm more complaining about like the way LLMs behave every time I interact with them. But like how do I say this? I would think that the most of the time I'm running code, I'm trying to figure out what the best way to express what I'm trying to do is. And like you skip all of that part when you get the LM to do it for you. And it might give you something that's like kind of right, like close to being right. But then you don't have all of the experience that taught you what was right, and so you're just as lost for when something goes wrong, which it will because it's a buggy piece of shit. I will click this link from Raggy. He's saying, yeah, I mean, I did see. Yeah, okay. So they've basically made what I made, just maybe with a little bit of a different, like an improvement here. But like, yeah, I think that that's fair. It's still wrong. Yeah, I don't know if this works, but uh, it's like close, right? This would get you on the right path at least. Uh, if you control the struct, oh wait, this is stood packed into array. Does that exist? No, right? So like, for the record, this is still fucking wrong, right? Also, the size of external struct equals 3. Oh, interesting. Oh, so this is funny. this we should check this because it is funny that like 2 of their 3 options are just straight up wrong, and I think option 1 might also still be wrong, but at least it's like close to the right answer. I just checked it. That's so funny. Opus is better if it's not correct. Yeah, so like, I don't know. Maybe we get to a world where these things don't fucking blow fat balls. But like, did I like make some changes here that made things stop compiling? Until that day, I will not really. I find it hard to believe that the people who are claiming that these things make their lives way more efficient are doing. I don't want to say anything of substance, right? That's kind of like the wrong thing to say. I find it hard to believe that these tools are outputting quality correct work. I'll say that. So, anyways, all of that to say though, I mean, you asked me have I used this, and my overall answer was kind of no. But maybe I'm a fucking idiot, but I just don't believe it. And I'm not going to like pay for tokens and like give these machines rampant access to my computer until I have a stronger belief that it's worth it. Even in the case where it was good, I would still struggle to imagine that I would commit, because unless I could run these models locally, then maybe, right? If the hardest part of writing code is admitting boilerplate, never admit that, yeah, that's fair. They do decently well in narrow problem spaces, i.e. web front end, where there's only one way to do it anyways. Yeah, I can see a world where you're using it as like doc filters. That doesn't seem that crazy. But I don't know. Every time I interact with them, I'm like, he's lying. So that's my take, but my take is not based in like working in the working world on implementing specs for things or whatever, right? So grain of salt. Anyways, let's fucking make a reader. Let's make a fucking CRC reader, baby. So this guy's gonna have a hasher. That is probably like tied to some existing hasher, right? Because we were saying before that we want to inject some parts of the initial state externally. So I think that this guy is like stood hash crc32. And we need to init this thing. So he's going to have some hasher. Hash crc32. And probably some like reader where he's getting his source data from. He's going to return one of these guys. Input stood Io.Reader, right? Okay. Then we are going to this, and then we have our interface, which is our stood Io.Reader that other people are going to call into. So we then are going to say hasher is hasher, easy. Input is R, and interface is a new reader, which needs to have seek set to 0, end set to 0. And I think that we can do completely unbuffered reading here. I think, right? Because this guy is not actually trying to do any work on the data. He's just trying to observe the data as it goes between 2 places, right? So I think that we can do that working with either the reader's buffer or the writer's buffer, one of the 2. Then we need our v table in here as well. And I think we just have to implement stream here. And I believe that's the only thing we have to implement. Which he's not liking, probably because our stream function doesn't exist. And here we have stood Io.Reader and stood Io.Writer and stood Io.Limit and stood Io.Reader stream error. It is indeed weird that the size of a 5-byte integer of U40 is 8 bytes in sig. Yeah, it is a little confusing. When you get to the underlying representation of those things, it kind of makes sense, but I agree, it is kind of weird. I use LLMs as sort of an easily searchable Wikipedia, where my main source of user Wikipedia is browsing stuff to see what exists, not actually how stuff actually works. Yeah, that's reasonable. And also like confidence checking yourself as well. Although it will always give you more confidence, so it's not when you know the reason. Yeah, exactly. Okay, so this guy we have like self is a pointer to our CRC reader. And here we have field parent pointer. So we have like a container, which is our CRC reader, which contains our reader at the field of interface. Boom. Then you have like the pass-through thing would be like self input stream to writer with limit, right? This is like the basic version of this thing. However, we need to like intercept what this is doing as it goes. So like what does the stream implementation of like a normal writer look like? Right? If we look at like maybe like stood Io.Reader, like can we look at like the file version maybe? File reader. This guy's gonna have like a stream function in here somewhere. Hello? Oh, interface is in an interface, which has stream in here. So what does like a read from file stream look like? They get a slice of data and then read into it. They get a slice to write into and then call that shit. So I think like they're making an assumption that the writer has at least some area to buffer writes into, and that's kind of like the expectation from this thing, right? So they were calling writable slice grid to give me at least 1 byte. And I think that you want to limit this thing. So they were probably doing some sort of limit on this thing. Yeah, so they're calling limit slice on that thing. Nice. So we're like, give me the slice of this slice according to the limit. Then we try to read, probably, read slice, which you're allowed to shorten your read if you want, into the destination. And this should return like actual written bytes. And then you should be able to call advance this by written. And while we're here now, we can say self hasher update with the data. So dest from 0 to written. Everything that you copied, just update the hasher as you go. And I think that's kind of it. Right? Like, I think that this is like almost like the super simplest bare bones reader you could make. And so now, can we make it so that, can we do something like, we still need to inject the header. So can we say that when we read a chunk header, we give him a CRC or like a hasher? Stood hash CRC. So each time we read a chunk, we create a new hasher. That seems reasonable to me. This guy, when we read, he is going to put the type string into the hasher. So this guy's going to take a hasher here. And in here, we can just do like hasher update type S. Boom. Okay. Why doesn't he like this? Wait, I actually don't understand. Because this guy takes in bytes, right? This is bytes. Oh, no E. I'm a dumbass. Okay. Then, when we are doing like this fizz stuff, we can say like var CRC reader is CRC reader init with hasher and R. Or is it self input here? Yep. And now we use this instead of self input, right? So we kind of take all of this stuff away. And we read using CRC reader now, right? And then we can go hasher final. And that should be good to go, I think. So we just need the data CRC is self input take 4. And last time, what did we do here? Did we did take int maybe? We read it as a big endian integer. So we can do take int as a U32 big. Okay. Feels good. Feels good so far. I think when we initialize this thing, I forgot to put an ampersand somewhere, like here. This guy needs a try here and not here. Okay. And where is that? Chunk header read R in common. Oh, it's because someone else uses, like, pull on the IDAP merger. He reads a chunk header, and we change the API here. Can we do this? CRC 32 in it like this, and then we can pass this in here. Just to make the API happy. And then another one in common zig 14. Hash CRC 32. And then this guy's gonna be mad. Oh, I guess in the header read, he actually discards the CRC himself, so he can make the hasher here. Yeah. He's mad because of some sort of print statement not working correctly. Zig build f reference trace to let me see the whole fucking shebang. Was it f reference trace like this? Nice. Okay. So in PNG 124. Oh. Try. What happens if your reader receives less than the minimum required for hashing? I assume you need at least int. I guess that means it's an invalid PNG. But that's a good question. Okay, what's going on here? Reach unreachable code. So when we are trying to take array n from PNG fizz read, so this guy internally is calling take int, which calls take array, which means that this CRC reader actually does in fact need a buffer in him, which is interesting. I was kind of hoping that you could get away with like pass through. But he needs a buffer specifically because Can you like link them? Probably not. Probably not. So is this doomed? No. Maybe. So you have file reader, right? And this file reader has like a buffer, and it's like by default reading into this buffer, and then we are trying to copy into the CRC buffer, right? Copy here so that like the PNG reader can like look at this buffer and like, or sorry, the fizz, I guess, can like look at this buffer and pull stuff out of it, right? So I guess in like if this is the chain, in reality, now this buffer doesn't need to exist, right? Which is kind of interesting because like in other cases it does want to exist. And I guess you could get away with making this buff really small, right? Like, because here we only need the buffer to be big enough for Fizz to read stuff out of it. In a lot of other cases, we will stream directly into the next buffer, but it just happens that in this case, in this particular case, this guy does need a buffer associated with him, which is interesting. Which is interesting. So I guess we do this, and in here we can say buff, CRC reader buff, and we can probably get away with making this guy like only like 10 bytes long. Segfault. That's interesting. Ooh, that's kind of fun. Is it use LVM? FLVM is true. Zig build, help. Oh, you can't force it here. You can't use it. You can't force it. Okay. What's happening here? The buffer thing kind of confuses me, I won't lie, especially when doing reader to writer chains, because the reader is going to have its own buffer and the writer also has one, but the writer writes the buffer you actually want to write to. I guess when there's a transformation, it makes sense, but for simple pass-through, it's a bit of a headache, I've found, unless I'm completely missing something. No, I kind of agree. I also struggle with it a little bit. It gets double confusing because sometimes the writer's buffer is the reader's buffer, which makes it even more confusing. Right, so in this case, I wonder, like, I think what might be happening... Am I segfaulting because we're, like, recursing forever here? We might be. Need a stood IO pipe, which just is a pass-through. Yeah, that would be nice. Although I think you would need a buffer for that as well. What am I missing here? So, here I'm calling... Oh, I used R instead of self-input here. I'm a dumbass. Okay. So now the question is what the fuck is going on? Oh, we're double discarding here, which we shouldn't do. But I still must be missing something. Oh, because he might read too much into this buffer now. Right, if he's consumed too much, then that's a fucking problem. Right? Like, hold on. Right? Like, we have file, CRC. This guy's file reader, I guess, file CRC reader. This guy's got a buff. This guy's got a buff. And then I'm kind of like there's a good chance that, like, when I'm doing to, like, fizz here, this guy is consuming, like, too much stuff, and we're, like, getting more than we wanted, right? So this buffer is a fucking problem. This buffer is a problem. I would prefer going back to having this guy be completely unbuffered. And that just means that we can't use those, like, take functions in this guy. Which is interesting. Like, can you... I guess you could do, like... You could do this yourself. Right? And you could do, like, ppx is studmem read int u32 buff big, right? Like, you could do this, but that's not very nice. Right? So the other option here is that this, like, CRC reader uses limited here, also unbuffered, which I think will do the right thing. So maybe something like this. So that will ensure that we don't go out of var limited. Let's try this. Oh, oops, I lost the CRC reader buff. Which we need. Let's try this. And then we also don't need GDB anymore. So let's fuck GDB. Fuck GDB. There we go. So that works. It is a little interesting. But I think it's fine. And in reality, you could make this even smaller, right? But I think actually doing, like, png fizz dot size for this buffer makes sense. And then we need to, like, validate the CRC somewhere, right? So we have, like, so before this was discard CRC, can we do validate CRC here? And we take the hasher. Maybe we just take the hash. Computed. And this is this. And then we have if computed is not equal to data CRC, return error invalid CRC, and then fix me. We should allow callers to warn here instead. So, like, maybe, like, we get, like, a diagnostic struct and we check it against that or something. You know what I mean? But, like, we shouldn't force errors on invalid because we might still want to read as much as we might want to do, like, our best effort. You know what I mean? And I guess discard CRC should still exist because we haven't done this everywhere yet. R discard all 4. Okay. Cool. So now we want here to be like validate CRC, hasher final, and input. Okay. Oopsies, validate CRC. My bad. And then final should be called like this. All right. Well, that is something. Now, I think this stuff we probably want to hold somewhere. So, like, I think that every time we do one of these, we're gonna want, like, limited. You know what I mean? Like I think that we want to keep track of where this thing is gonna end. So let's have ourselves hold the limited version of this thing in the CRC reader. He is going to create, like, we're gonna have a limit here. Len, maybe. And in here, we have limited is R limited. I guess this could be a limit. Maybe it's just dot limit here. Yeah. And we'll put a note, unbuffered reading should be fine since we only ever do direct pass through to writer slice. Right? I believe read slice short should not do anything crazy here. Right? He should just call read vec, which calls stream under the hood. Yeah. Well, default read vec does. And the writer here is where we're going. Yeah, I think that's fine. I think that is fine. Okay, sure. So then when we call this guy, we pass in the limit here now instead. So this guy gets self input with limited chlen like this, which makes this go away. Cool. He's still happy. And there we go. So at some point we wrote actually write CRC reader. And then now we're on like integrate. Integrate. Okay. So now we just have to find everyone who calls discard CRC and figure their shit out, right? So IEnd has no data associated with him. So he's going to he can just call validate CRC here with the current hasher output because like there's nothing else to put in here because this length is 0. So he passes, which is good. Right? If we just to check here, if we did +1 here, something would go wrong, right? He'd say invalid CRC. So we do know that that's working. Cool. So that's 1. Discard CRC. Who else is calling this shit? Header. So here we want to do the same thing where we do like header buff. We can call this like CRC reader buff. Maybe we want to give him a lot. Probably he doesn't need that much, right? We're only taking this much stuff. But you know, all of this, given that everyone's doing CRC checks, the actual original file input buffer does not have to be very big. I don't think. Not 100% sure there, but I think that's correct. So CRC reader. Okay, this CRC reader now has to live in common because it's being used all over the place. So CRC reader now, this goes in common. Okay, so now this guy can go CRCR is CRC reader init with our hasher, with our reader, with our limit, which is chunk len here. So this actually goes below the chunk stuff. Boom. And what was the last thing? The buff. Okay. Easy. And then everywhere here, we use CRCR instead. Boom, 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 boom. And it's not CRCR, actually, it's a interface. Boom, 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 boom. Easy peasy. Easy peasy. And really, like, this is fine. So validate CRC of hasher final and R. Okay, in PNG now CRC reader is not defined, so it has to come from common dot. And init probably has to be made public. Okay. Nice. Nice. And now the last one, there's a couple more actually. Consume outstanding. So when we give out outstanding unknown data, this stuff should also get CRC checked. So unknown is now no longer limited, but I believe that this guy has the hasher here. As well as the reader, which is a stud, which is just our CRC reader now, right? And when we make this thing, we give him almost the same shit. So, I think we have to do like this. Self outstanding reader is equal to unknown is equal to undefined. So this should set the tag such that we can now access this guy. So we should be able to go now. Hasher is equal to init. And we should be able to update with. Oh, I guess we copy the hasher. Yeah. And then when we make our data reader or whatever, sorry, the reader, here we give him the address of this hasher. And we have the underlying reader of self input. We have ch.len as the limit and reader buff as the buffer. That sounds kind of right. And then we can return this thing and we can say like this. Then when we're in unknown, we say discard everything, fuck off, and then check the fucking hash. So here we have like UR hasher. Okay. Final. And input. Seems kind of right. Okay, what's he pissed about? CHLen here needs to be a strong type of limited. Okay. Reader buff is already a slice. Let's fucking go, dude. Let's fucking go. And then just one more time, we do a little check here. Okay, well. This PNG does not have unknown sections. That's why. But this one should. Okay, bad news. He's falling the fuck over. Bad news bears. Can we hold undo a little bit just to check that this PNG was working, like this was working here? Okay, so it is the latest stuff that we just added for this like unknown reader stuff. So I bet we're getting stuck in this discard remaining call, which is interesting. We're probably like spam calling our CRC reader read stream or something, and this guy is probably failing to propagate end of stream. So is there... So there's read slice short, read slice all. Is there like read slice like at least or something? Like I need to make sure that we get at least one byte, right? I guess if we can just check here. If written is equal to 0, return error end of stream, maybe? Nice. Nice, dude. And then down here, wherever the fuck we were doing that, like, check here, let's just make sure that if I write, like, +1 here, invalid CRC. Let's fucking go! So all of our unknown segments are handling this correctly now as well. And now the last one is here. So in our IDAT merger, right, so there's a bunch of data segments back to back. We need to CRC check them all, which means that this guy probably owns... I mean, he could hash it manually in here. Like, does he really need to use the reader pipeline for this? I mean, it is nice to just be able to call input stream and input discard. Yeah, sure. So his input, he wants input to be a CRC hasher or whatever. And then he needs to be able to like reset him as well every time he finishes a block. Because this merger is going over many blocks at once. Okay, who calls this? PNG data reader. Right, so this is kind of doing the entire pipeline of source, IDAT, decompressor, filter, application, output. So you could put CRC reader here. And then just like reset on the length. It really feels more like it belongs here, right? Source, merger, then CRC, then decompressor. And it kind of feels like it's almost like out of band. You know what I mean? Like it kind of feels like CRC reader. It really does feel like it belongs in the merger. Okay. Which makes me think, again, I'm kind of back to the idea that throwing in an extra, like, reader, an IO reader here, was actually be more complicated than just doing it ourselves. I think. So let's do this. Input. So here we want to do the same thing where we do like W writable slice greedy, at least one, limit slice, make sure that we have some area to work with, right? Then we call self input read slice short into the destination. We call W advance with the written like this. We also want like we have our own restrictions on limit here, so we kind of want to do this. Self clamp limit, then slice that thing. Cool. And then what? Block remaining is written. We return written. Okay. And then we have if written equals 0, return error stream, end of stream, right? To kind of do the same thing we did over there. And now the only thing to do is actually update the CRC. So we have a hasher in here. And we call update here. Okay. That seems reasonable. I think discard now. Like, we need to do the same thing here. Fix me, check CRC area. So these two guys, discard can no longer discard, but he can use like his own local buffer instead, right? So we can do like stream inner maybe of self into buff, right? And then he can kind of do this part. Yeah. And then this is like stream inner dest, and we can like okay, so now we have like internal tracking is handled nicely in here. Written at 0, end of stream, already covered. Does discard return end of stream? Yes, it does. So this only has to handle advance and then write, and then here we can call stream inner, but here we'll use our own buffer. Right? And we can just kind of fill this up as much as we want. You know, something like this. Something like that. And I guess we need to limit this to some extent. So we were going to do like, make sure that we limit this with the amount that they were willing to discard. That seems like not crazy. Making crabs, thanks for the tier 1. Much appreciated. Right, I think that all kind of makes sense. And so now all we have to do is, instead of discarding CRC here, we validate CRC with hasher final. And then we do self hasher is equal to a new hasher. We like reset him like this. If this catch here, we return, we say like self error, which we don't have yet. Return error read failed or something. Is that what it's called? Yeah. And then we put a fix me in here. Like allow success, like allow override to override and succeed. Seems reasonable. Seems reasonable. And then all we have to do is put the chunk name in here. Right, so somewhere we are peeking header. If this succeeds, then we do self hasher update with IDAT to get the tag in there. And then I think we're fine, right? Oops, zig build. Okay, we do need our hasher, huh? All right, you caught me. Ensure block in data. I guess this should actually be more like we should do the conversion below, I think. So we'll do this. Return error read failed, and then here we'll put the fix me allow caller override. Okay. We are getting CRC failures here, which is not good. I think that our first guy needs to get the how do you say this? The header thing in here. Right. We kind of need to do this. Let's fucking go, baby! Oh, oh, oh. I think that we validated them all. I think that's all of them. Discard CRC. Literally none fucking left. Dude, that's pretty hype. That is pretty sick. Okay, so what did we do? So I think that the only reason this was really needed was for the unknown parsing, right? Like, technically, for anything that we're processing ourselves, we don't really need to, like, nest the readers like this, because we could just, like, pull it. We could manually update the reader as we go. However, it will be easier for us to just assume that the stream does it, right? The only reason that we didn't use this in that other place, in the IDAP merger, was just because it was easier to implement ourselves there. And I think that's like a choice that we get to make sometimes. Not bad. Not bad. All right. Okay, let's call it there for the main segment. And then Twitch viewers, let's continue on with some reading, I think. I still want to do some investigation on some of like the color stuff that is coming up next. So we're not going to end stream, but we will call this the end of the YouTube video. If you're watching on YouTube, thanks for watching. If you like what you saw, we stream most days. We aim for 12:30 to 4 Pacific time. Check out the Twitch. As I just said, there is more stuff going. There is more stuff coming today on the stream, but that doesn't go up on the YouTube. If you want VODs of that stuff, it goes up on Patreon, YouTube member on Twitch. If you support there, you get knowledge of help, that you're helping the stream continue. I make like 1/10 of what I made as a software developer. So like this is not sustainable long term. But every dollar I make makes this continue a little bit longer. So please consider, but obviously no pressure. I think that's it. YouTube, peace out, and Twitch, let's keep going.